Hello everyone, I am Dr. Anita Thomas. Today we shall discuss some more problems from the exercises of section 1.5 exact equations. We follow the text differential equations theory, technique and practice by G.F. Simmons and Stephen Krantz. See section 1.5 more problems on exact equations. What's an exact equation? An equation of the form m of xy dx plus n of xy dy equal to n of xy dy equal to 0. If it can be written as this form, that is a total derivative of a function f of x comma y, then we say that it is exact, or this condition, if it satisfies this condition, we say that it is this differential equation is exact, and the solution is f of x comma y equal to c. For the theory, do watch my previous video. See, shall we move to problems? First one, minus 1 by y sin x by y dx plus x by y square sin x by y dy equal to 0. M is this quantity and n is this one. Both the terms m and n are product of two functions. M is a product of two functions of y. So we need to differentiate partially with respect to y. We need product rule for differentiation, and we get this quantity, and n is again a function of two product of two functions of x by y square and sine of x by y. Here also we need product rule, and thus we got these two quantities, dou m by dou y and dou n by dou x, but they are not equal, therefore it is not exact. So we shall move to next problem. Next problem, there are so many functions, product of two, so many functions. So first it is e raised to y square minus cosec y cosec square x into dx plus 2x y e raised to y square minus cosec y cot x into dy equal to 0. M is this one and n is 2xy e raised to y square cosec y cot x. So for differentiating this first term with respect to y, we need logarithmic differentiation. You take it as u is equal to e raised to y square, then ln of u is equal to y square ln of e, then you will get differentiating, you will get this quantity. So we shall consider dou m by dou y, it is 2y e raised to y square. Then with respect to y, this one is a constant, therefore cosec y, derivative of cosec y is minus cosec y cot y, thus we get plus cosec y cot y cosec square x. Similarly, differentiating n with respect to x, we get 2y e raised to y square plus cosec y cot y cosec square x. Now both these are equal. Both of these expressions, dou m by dou y and dou n by dou x, are same. Therefore, the equation is exact. Now our aim is to find out f. It is m. We denote m in another form, dou f by dou x. So m is dou f by dou x, which is equal to e raised to y square minus cosec y cosec square x. So for getting f, we need integration by x. So integrating with respect to x, f is equal to integral of this quantity with respect to x. That is, this is a function of y. So it is constant when you integrate with respect to x, so we get it as x e raised to y square, then plus cosec y cot x, then the constant of integration is phi of y, because we are integrating with respect to x, y is considered as constant, therefore in the place of arbitrary constant we write phi of y. Now since this dou f by dou x is m and dou f by dou y is n, we need to differentiate this f with respect to y partially. So we get this expression and we get phi dash y. See, these two are equal. LHS are equal. So we equate both the terms, but we get 2xy e raised to y square cosec y cot x plus phi dash y equal to this one, equal to n. N is from our question. So n is this one. So we get phi dash y as 0 and we need phi of y. So integrate with respect to y, we get an arbitrary constant. Thus from equation number 1, f of x comma y is written as x e raised to y square plus cosec y cot x plus d equal to c. That is f of x y equal to c. Now we follow the pattern of our text. We write it as x y square, x e raised to y square plus cosec y cot x equal to c tilde, where c tilde is c minus d. Now the third problem, 1 plus y square sine 2x dx minus 2y cos square x dy equal to 0. So m is this quantity, n is this one, dou m by dou x, dou y and dou n by dou x. By applying trigonometric result here, we found that both of them are equal, so they are exact. And I used a method of inspection. By inspection, I found the solution here. See, dou f by dou x is m, which is 1 plus this quantity, and dou f by dou y is minus 2y cos square x. Therefore, there is a f should contain a term whose derivative with respect to x is 1, derivative with respect to y is partial, with respect to y is 0. That means that unknown function is x, that f should contain x. And see the next two terms in these two expressions. There is an unknown term whose derivative with respect to x is y square sine 2x, and there is a function, and the same function should give us, while differentiating with respect to y, minus 2y cos square x. Then guess for that function, it is minus y square cos square x. When you differentiate this function with respect to this term with respect to x, you will get y square sine 2x. See, y square, this result also applied here. Similarly, here also. That means the solution is x minus y square cos square x is equal to c. Directly we can find out the solution by inspection. You just inspect the terms carefully, then you can find out the miracle behind this expression. That means there is a term whose derivative partially with respect to x is this one, and its partial derivative with respect to y is this one. Then guess for the function, it is minus y square cos square x. Now next problem, find the value n for which the equation is exact, then solve for that value. See, this is the question. What is m? M is x plus y e raised to 2xy, and n is capital N is small n into x e raised to 2xy. So our aim is to find out n, provided we are given that this is exact. So find dou m by dou y. It is e raised to 2xy plus y into 2x into y e raised to 2xy. This its derivative 0. And dou n by dou x is 2nx into y e raised to 2xy plus product rule is applied, n into e raised to 2xy. So since given that the question is exact, so dou m by dou y is equal to dou n by dou x. So equating these two expressions, we can find out that the value of n is 1. Equating the like terms, these two first and here first term, here last term, they are equal term or equivalent terms, and these two are equivalent terms. So we equate and find that n is equal to 1. So do these problems. Then there is an important problem here, and we have to complete it with 2 minutes. So solve y dx plus x dy by 1 minus x square y square plus x dx is equal to 0. See, whenever you see such an expression y dx plus x dy, you must understand that there is a function whose function x into y, whose total derivative is y dx plus x dy. So before doing the problem, see what I did here. 1 by x 1 minus x square y square can be written as 1 by 1 plus xy into 1 minus xy. Now what is the total derivative of ln of 1 plus xy, which is 1 by 1 plus xy into x dy plus y dx. Then this quantity d of ln of 1 minus xy, that is 1 by 1 minus xy into x minus xy. The total derivative is minus x dy plus y dx. Now left them, and now consider the derivative of the total derivative of half of ln of 1 plus x plus y minus ln of 1 minus xy. Now derivative of total derivative of half of ln of x1 plus xy minus ln of 1 minus xy. Here is a curly bracket, I left that one. So from here what happens? See, d is an operator. So this means d of this one, half of d of this one minus half of d of this one. See, we already found that you apply here and take the LCM, you will get the value as half of 2 times x dy plus 2y dx divided by 1 minus x square y square. 2 get cancelled. Then we will get this term. Thus I wrote here d of half of ln of 1 plus xy minus ln of 1 minus xy plus this x dx equal to 0. So solution is obtained by integral of this quantity. So integral of the total derivative of this expression plus integral of x dx equal to, I took the constant at c by. What happens? Derivative and integral. They are, and we get half of this function. The integral of total derivative of function means that function itself, half of ln of x plus y minus half of, here also I left a bracket, sorry, plus x by y, x square by 2 equal to c by 2. Thus we get ln of 1 plus xy by 1 minus xy, applying log a minus log b. From this expression we write it as, from here we write it as ln of, so multiplying throughout by 2, remember here is a bracket and here also a bracket. Multiplying all these 2 by 2, we get the answer as ln of 1 plus xy by 1 minus xy plus x square equal to c. Thank you. Do watch my next video.